Hello student, I am Dr. S.L. Munde, Assistant Professor Department of Mathematics, Sri RLT College of Science, Akola. In previous lecture, we have seen some problems on a dominance property. We have seen a rule of the dominance property and one or two problems on a dominance property. So in this lecture again we will see some other different types of the problems on a dominance property. So what is the second problem? Solve the following games. This is the given games by using dominance property, because here P of matrix is 3 by 3. Okay, so that means we will solve this problem by using dominance property. Okay, so what is the solution? So write down the given P of matrix. The given P of matrix is can be written as, so let us we consider this is a player B and this is a player A. So player A using three techniques, that is A1, A2, A3 or strategies, and player B using three strategies B1, B2, B3. And these are the P of for player A and for player B. Okay. Now what is the dominance property? Dominance property is used to reduce this 3 by 3 P of matrix in the form of 2 by 2 P of matrix. Okay. So now we will use the dominance property to reduce this 3 by 3 P of matrix into the 2 by 2 P of matrix. What is the dominance property? So in if you what is the first step? First step means column operation, then second step will be the row operation. What is the first? Okay, column operation is select uh, any one of the column, all the elements of the column greater than equal to the all the elements of the other column. Okay, so if you observe here, the first column, all the elements of the first column is greater than equal to all the elements of the second and third column. Okay, that means we can say that first column is dominated to the second column and third column. Okay, so therefore we will remove here the first column from this step number 1. Okay, so because of first column is dominated to the second and third column. Okay, so therefore we will remove the first column. Then the reduced P of matrix can be written as, that is A1, A2, A3, B1, B2, B1, B2. These are the P of matrix elements. Okay. Now here if you observe, the given P of matrix reduces in two columns. Now we want this P of matrix into the two rows. Okay, so for that here we will use a row operation. Row operation means here you have to select any one of the row. All the elements of the any row is less than equal to the other elements of the other row. Okay, so if you observe, the all the elements of the first row is less than equal to all the elements of the second and third row. Okay, so this is first row, all the elements of the first row is less than equal to all the elements of the second and third row. Okay, so these elements are uh, less than equal to time. Okay, so here first row is dominated by the third row, because all the elements of the first row is less than, okay, sorry, here first row is dominated to the not a second row, only third row. All the elements of the first row is less than equal to the all the elements of the third row. A1 is less than equal to A3. Okay, that means we can say that this first row is dominated to the third row. That means here we will delete the first row, because dominated row will be deleted. Okay, the required after deleting the dominated row, then the reduced P of matrix can be written as, that is 5 minus 1 0 2 B2 B3 A1 A3. Okay, so this is the 2 by 2 P of matrix. Now we will solve this problem by using previous method, 2 by 2 P of matrix. Okay, so here we will find out the row minima. Row minima means the smallest value in each row, that is minus 1 and 0. So find out the maximum. Maximum means maximum value in row minima, that is it is denoted by lower v bar equal to 0. Then we will find out the column maxima, that is the largest value in each column, that is 5 and this is 12. Then find out minimax. Minimax means smallest value in column maxima, and it is denoted by the upper V bar. Okay. So if you observe from this P of matrix, maximin is 0 and minimax is 5. Okay. And here no one here, if you observe from this P of matrix, there does not exist any saddle points. Okay. That means we can say that this player A and player B both are using the mixed strategies. Okay. So therefore we will consider the mixed strategy for player A, and which is given as A1, A2, A3 with pay of P1, P2, P3. And mixed strategy for player B, B1, B2, B3, Q1, Q2, Q3. This is the total mixed strategies. Okay. So if you observe here, A1 is deleted and B1 is deleted. Therefore, P1 will be the 0 and Q1 will be the 0 here. P of, okay. P1 is 0 and Q1 is 0. Okay. And condition will be P1 plus P2 plus P3 equal to 1. P1 is 0. This can be written as P2 plus P3 equal to 1. And this is the second condition, Q1 plus Q2 plus Q3 equal to 1. Here Q1 is 0. So this condition will reduce Q2 plus Q3 equal to 1. Okay. Now here we will find out only P2, P3 and Q2, Q3. Okay. So from the given P of matrix, A11 is 5, A12 is minus 1, A21 is 0 and A22 is 1, 2. Okay. So therefore by using the formula for P2, so formula is A12 minus A21 divided by A11 plus A22 minus A12 plus A21. Okay. So putting all the values in this formula and solving, we will get, that is P2 is minus 1 upon 18. Then similarly we can find out P3, that is 19 upon 8. Okay. So this is the values of P2 and P3. Then similarly we can find out the Q2. Q2 is A21 minus A12 divided by A11 plus A22 minus A12 plus A21. So putting all the values from the given P of matrix, we will get Q2 is 1 upon 80. So similarly we can find out Q3. Q3 is 1 minus Q2. So we will get Q3 is 17 by 18. Okay. Then finally we will find out value of the game V, and which is given by this formula. Okay. So V equal to A11 into A22 minus A21 into A12 divided by A11 plus A22 minus A12 plus A21. So putting all the values from the given P of matrix and solving, we will get that is V equal to 10 by 3. So this is the value of the game for the given P of matrix. Okay. So now we will find now we will write the optimum strategy for player A. Therefore the optimum strategy for player A is A1, A2, A3. P1 is 0 and P2 we already find out, that is minus 1 upon 18. P3 is, that is 19 by 18. And optimum strategy for player B is B1, B2, B3. Q1 is 0 and Q2 we already find out, that is 1 upon 18, and Q3 is 17 by 18, and the value of the game fee is 10 by 3. Okay. So this is the complete second problem of the dominance property. Okay. Now we will see the third problem of the dominance property. Okay. So what is the third problem? So here we have to solve the following game, 1, 2, 3, 4, 1, 2, 3, 4. This is the 4 by 4 payoff matrix. This is the 4 by 4 payoff matrix. We have to reduce this 4 by 4 payoff matrix by using the first dominance property. Okay. So if you observe, so what is the first step? That is column comparison. So if you observe, no one column in this payoff matrix is compared to the other column. That means no one column is greater than equal to the other column. Okay. So here column case will be is not applicable. Then we go to row operation. Okay, column operation here fail. Therefore, we will go to row operation. Okay. So if you observe from this row 1, 2, 3, 4. if you observe first row and third row, here all the elements of the first row is less than equal to all the elements of the third row. Okay, all the elements of the first row is less than equal to all the elements of the third row. That means we can say that here the first row is dominated to the third row, because all the elements of the first row is less than equal to all the elements of the third row. So therefore first row is dominated to the third row. So here we will cross the first, here we will delete the first row from this given payoff matrix. Then this payoff matrix can be reduced in the following form, and this can be written as remaining elements, that is A2, A3, A4, B1, B2, B3, B4, and this payoff matrix, that is 3, 4, 2, 4, 4, 2, 4, 0, 0, 4, 0, 8. Okay. Now again we will use here dominance property. Okay, so what is the first step? That is the column operation. Column operation. Okay, if column operation will fail, then we will go to row operation. Okay. So here if you observe, all the element of the first column is greater than equal to all the elements of the third column, and hence we can say that all the first column is dominated to the third column. Okay, all the elements of the first column is dominated to the third column. Okay, so therefore here we will delete the first column from this payoff matrix, then we will write the other remaining elements of the payoff matrix, that is 4, 2, 4, 2, 4, 0, 4, 0, 8. Okay, so this is the reduced payoff matrix. Okay, now if you observe, this is reduces in 3 by 3 payoff matrix. Okay, but not in 2 by 2 payoff matrix. So again we will use here a dominance property. Okay, so again here we will use here dominance property. If you observe from this payoff matrix, no column is compared, no one column is greater than equal to the other column. Okay, that means here column case is fail. Then second case is row operation. Second case is row operation. If you observe from this payoff matrix, no one row is all the elements of the any row is not less than equal to all the elements of the second row. That means here column operation and row operation, both cases are fail. Okay, so then what is the next step? Okay, now if you observe from this payoff matrix, the first column and second column, if you take the average of first column and second column, okay, if you observe from this the first column and second column, which is the average of the second column and third column, if you observe the average of second column and third column, the addition of these two column, or we can say that average of these two column is greater than equal to the is greater than equal to this column. We can compare if you take 4 to 4 and average of these two column. Okay, so here we have given, now in the reduced payoff matrix, no single row or column are dominated to the other row or column. For column first dominated to the average of the second and third column. Okay, here we have given, that means if you take the average of second and third, 2 plus 4 divided by 2, that is 3, then 4 plus 0 divided by 2, that is 2, then 0 plus 8 divided by 2, that is 8. So you will get 3, 2, 4, and so here is 4, 2, 4. That means all the element of the first column is greater than equal to all the elements of the average of the second and third column. Okay, that means here all the elements of the first column is greater than equal to average of the second and third column. That means the first column is dominated to the second, average of the second and third column. So therefore we will delete first column. Okay, here deleted the first column. Okay, so here deleted the first column. then the reduced payoff matrix can be written as, that is 2 4 4 0 0 4. Okay, instead of 3 2 4 we can write 2 4 4 0 0 8. Okay, now here now the here given payoff matrix is reduces in two column. Okay, now we have to require to reduce this payoff matrix in two rows. Okay, so if you observe, no one rows is dominated to the other rows. Okay, that means here we have to take the average of the some two rows and then we will compare to the third rows. Okay, so again here no single row is dominated to the another row. Okay, the first row is dominated by the average of second and third row. If you observe from this given payoff matrix, if you observe 2 and 4, first row is is less than equal to average of the second and third row. So if you take average 4 plus 0 divided by 2, you will get 2, and this is 0 plus 8 divided by 2, that is 4, 2 4. Okay, the average of second row and third row will get 2 and 4. Okay, so that means we can say that the first row is dominated to the average of second row as well as the third row. So therefore first row is deleted from the given payoff matrix. Okay, first row we will delete here. Therefore the given payoff matrix can be written in 2 by 2 payoff matrix is, that is A3 A4 B3 B4 4 0 0 8. Okay, so which is the which is the form of the 2 by 2 payoff matrix. Now we can easily solve this 2 by 2 payoff matrix by using previous methods. Okay, so again here we will find out a row minima, and then maximum, column maxima, minimax, then we will find out the P1 P2 Q1 Q2 and the value of the game V. Okay, so now I will give to you the remaining part of this problem for the homework. So you have to solve this problem from this to find out the P1 P2 P1 P2 P3 P4 and Q1 Q2 Q3 Q4, and then the value of the game. Okay, so if you see here, the solution of this problem is given here. Okay, so you have to solve this problem. Okay, so dear student, here we have completed the dominance property problems. So in next lecture we will see the next method, that is a graphical method. Okay.